Good morning, welcome to
SummerMath number 6.
SummerMath6. Okay, so suppose I have 6 different books, 2 of which are math books. And how many ways can I stack my 6 books on a shelf? Oh, if I want a math book at both ends of the stack. Okay, so I have 6 different books. Whoa. I got a chess book, Shadows of the Mind, Rediscovered Ben Graham, Origins of the Crafts. None of those are math books.
Yeah.
Then I have a book called Algebra.
Which is definitely a math book.
And then I have a book called The Math Book.
Which is a math book.
Is that a math book?
Yeah.
And I want a math book at both ends of the stack. This is heavier than I thought, and harder to balance than I thought. But so this would be a valid arrangement, for example. Right? And the question it's asking is how many arrangements are there?
Well.
Okay. So first of all, do you both understand the problem?
Yeah. Yeah. So.
Okay.
What I think is we can draw our slots.
Okay.
6 slots, and we have a math book at both ends.
Okay.
So then we have, let's call our books A, B, C, and D.
Okay.
To go in those.
All right.
And so this just looks like arranging these 4 in here.
Okay.
Because the math books have to be here and here.
That's true.
So that means there'd be 4 ways to put a book in there.
All right.
Yeah, and then there's 3 ways to put a book in there, 2 and 1.
Okay.
So now
So
we've got to multiply. We've got to multiply this,
Okay.
So we have, it's 4 times 3 times 2 times 1.
which is 4 factorial.
Which is?
Which is 24.
Okay. Do you think that's the right answer?
Yeah.
Yeah, because the math books are just are stationary. They have to be there.
Okay. Do you think that's the right answer?
Yeah.
That is not the right answer. There's a little tiny mistake.
Well,
Let's look at our stack. Let's see if we can pick out the mistake. Okay. So this is a valid arrangement, right?
Yeah. Because there's the 4 non-math books are there.
So what did you do in your solution?
well, I just kept the math books here,
Okay.
and then I picked 1 book to go here, 1 book to go here, 1 book to go here, 1 book to go there.
Okay, so you put a math book on the top like we have, a math book on the bottom like we have, and you scrambled up the middle, and you said there's 24 ways to scramble up the middle.
But the math books can be switched.
Why is that?
Because you don't know which math book can be on each.
Right, see it says, suppose I have 6 different books, so the math books are also different.
So M1 and M2.
Okay? Do you see that?
Yeah.
'Cause I can't hold this up for much longer because it's going to crush me. Ah. Okay?
So which means there's actually 48.
Okay.
Because
Why are there 48?
there's another set of arrangements with the math books switched.
It's 24 more different
Okay.
arrangements.
So in this bucket and this bucket, how many ways do I have to choose the first book?
2.
2. Okay?
Yeah.
Alright. And how many ways do I have to choose this one now?
Then 1.
1. Okay, so in other words, let's see if I can pull this stunt off. This arrangement,
Yeah.
can you pull the middle 4 books out? But keep them in the same order. Is different than that arrangement, right? Because now last time I had a math book on top.
Yeah.
Now I have the math book on top.
Yeah.
Okay? So you got to be really careful. So that shows that these problems can get subtle, right?
Yeah.
Yeah, just because it's a math book on the end doesn't mean the math books can't be switched around. All right. Good job, guys.
Yeah.
Having fun with these
Yeah.
learning how to count? That was a neat problem.